So rate of change, or M, is a ratio that shows how one variable changes another. Now, on a linear graph, this is called the slope. Rate of change is the slope, or our M. Okay? Slope from a graph is written as a ratio, aka a fraction, of the vertical change, aka the rise, over the run, or horizontal change between any 2 points on a line. Now, the slope will remain constant for any 2 points on the line. So from here to here, that's a slope. From here to here, it'll be the exact same slope, just as long as all those points are on the same line. Okay? Slope is written as a fraction in, what do you think all fractions should be in? Simplest form. Okay? All fractions are in simplest form. Now again, we're starting our linear functions unit. That is y equals mx plus b. Today we are highly focused on slope, which is the variable m in y equals mx plus b. We're focusing on the m today. Focusing on the m. Now this should be like a review from last year. There are 4 different types of slope. Can someone name one of them? Positive slope. One at a time. Let's just do one at a time. Positive slope is one of the slopes we have. Okay? Which means we are going from left to right in an upward direction. Okay? Now, what's the opposite of positive first? Negative. Okay? So now we have negative slope, which goes downward from left to right. Okay, checkers, what was the other one you just said? Undefined. Okay? Now, an undefined slope means I have on my graph a line that is straight up, straight down, aka a vertical line. Okay? What's the opposite of vertical? Horizontal. Now, a horizontal line is not an undefined slope. It is a slope of 0. Yay! 0 slope. 0 slope. Does everyone have a calculator? Okay. We are going to need calculators at some point here. Finding slope on a graph, which is what we're going to talk about first because it's the easiest, is m, which means slope equals rise over the run. The rise over the run. So the steps to find slope on a graph, first is to find 2 perfect points on the line. Luckily, in all the graphs that we have on the notes, we already have perfect points drawn for us. So we're going to use those. Now, when I do rise over run, I have a specific goal that I want to create. I want to create this. What did I just create? What type of triangle? A right triangle. So when I do the rise over the run, I'm trying to connect the 2 points that have been chosen and creating a perfect right triangle using those 2 points and using the slope of the line as my hypotenuse. If y'all remember that word, the hypotenuse, okay? And these are my legs. Now rise, what do you think I'm doing when I rise? Do I go up and down, or do I go left and right? Up and down, okay? So in this situation, I go up on my right triangle. I go up 1, 2, 3, 4, 5, 6, 7. I go up 7, so my rise is 7. The denominator, my run, means I'm going horizontal, was 1, 2, 3, 4. So step 1, identify 2 perfect points. Step 2, create your right triangle. Step 3 is simplify your fraction if possible. Can I simplify that? I can? Can that reduce in any way, shape, or form? Okay. Could you change it to a mixed number? Technically, yes. However, never take an improper fraction slope and make it a mixed number. If we're finding slope and you get an improper fraction, keep it an improper fraction. Keep it improper. All right. I forgot one step. I did forget a step. This step would be identifying what type of slope do I have. There are 4 different types. What type do I have here? Positive. Okay. Now, the reason why I'm saying we need to identify the type of slope is if my slope is positive, but you give me an answer with a negative number, did I have a positive slope? No, I did something wrong and I need to double check my work. Okay. Problem number 2, step 1 or 1A should be identify the slope, which is, in this case, a negative slope, which means my numbered slope, the slope of the actual value, should be what type of number? A negative number. Okay? So I'm going to do my rise and my run. I have 2 perfect points. Again, they are already given to me. If you really look at the paper, they are already given to me. Step 2 is to create your right triangle. So I'm going to create my right triangle here. I created my right triangle to give me my slope, my rise, and my run. Now, to go from this point to this point, my rise, is it going downward or upward? Down. If I'm going down the y-axis, is that negative or positively moving? Negatively moving. How far did I negatively move? Good. My run is 1, 2, 3, 4, 5, 6, 7, 8, 9. I have a negative divided by a positive. If I simplify that, do I have a negative number? Yes. Okay, so we've identified our slope correctly. Second thing I need to think about is, can this fraction be reduced to what? Negative 1/3. Once I reduce that fraction, I now have my slope. Is this jogging some memory banks? Hopefully, a little bit maybe. Yeah. Yeah, basically the denominator will always be positive. The negative comes from the numerator. That's a good way of thinking about it. All right. What type of line do I have here? 0. Why is it 0?
Because it's horizontal.
Because it's horizontal, which means I'm going to pick 2 random points. I can still do a rise over run. Okay? The only thing is, did I rise at all? No. So you know how I put that in number form? 0. Did I run?
Yes.
Yes. I chose 2 random points. How far did I choose to run?
4.
4. Now, can I simplify that fraction? Yes.
Yes.
In your calculator, do 0 divided by 4. What do you get? 0. If you get 0 as your simplified fraction, your slope is the word 0. So if the number you get is 0, you write the word 0. Does everyone see that? Okay. All right, let's talk about this one right here. I'm going to pick 2 random points. Did I rise at all?
Yes.
How far? 5. Okay. In this situation, I rose 5. Did I run at all?
No.
On your calculator, do 5 divided by 0. Tell me what you get. If you're telling me 0, then you didn't actually type it into the calculator. Error. 5. 5 divided by 0 should give you error. Oh my gosh. Error. If I get an error message, my slope is undefined. Because it's an error. I can't define it as 0 or anything else because there's an error. It's undefined. Tim is having a panic attack over there. Okay, turn the page. Is that the same thing? That is the same thing. They doubled the pages. No, that's not the same thing. I think we lost a page. We're good. Moving on. Okay, we are going to do examples 5, 10, 11, 13, 14, and 16. So we're going to do 5, 10, 11, 13, 14, 16. Okay. Example 5 first. Identify your type of slope. What type of slope do I have? Positive. So my numerical value of the slope should be a positive. Okay, so let's make sure we do that correctly. All right, I'm going to find points on the graph. They are the points that it gives me. These are the points that it gives me. Once I find points, okay, I now need to draw a what? A perfect right triangle. So I'm going to draw my perfect right triangle. If I have a positive slope, I always like to draw my my perfect triangle on the top side. That's just me. If I have a negative slope, I like to draw it on the bottom side of the triangle of the line. It's just me. You do you though. Okay. Rise first. 1, 2, 3, 4, 5. I rose 5. And I ran what?
3.
Can that be reduced? So is that my answer? Yeah. Woo! Finding slope on a graph is one of the easiest things ever. Problem number 10. Nice. Which means my slope numerically should be negative. Okay, remember the numerator will be your negative. So I have my 2 points. I go down to my triangle. Then I run. There's my perfect right triangle. I went down how many units? 5. So negative 5. So I'm putting -5 because I go down. Remember, when I go down, when I draw my right triangle, when I go down, that's negative. Okay? Then I go to the right, how much? 1. Now, can that be reduced? To what? To just -5. Because it is over the number 1. So I can write it as just -5. Would I count it wrong if you gave me that one? No, because technically that's simplified also. I can just make it cleaner. Questions, comments, concerns, tribulations, or quandaries? No. There are none. There aren't any. No. 11. What type of slope do I have? Say it louder because you only said half the word. Undefined. How do I know that it's undefined? Straight line is not enough. Straight line is still not enough verbiage. Vertical. Because technically a horizontal line is also a straight line. Technically this is a straight line. It's just angled. Vertical. Okay. 16. What type of line do I have here? A horizontal line, which means my slope is 0. Good job. Now you get to do 13, 14 on your own. Shouldn't take too long. Hopefully. I didn't take attendance. All right, that shouldn't have taken too long. Lucas, could you go up to the board and tell me what you get as the slope for 13? You can take your paper up there with you. You're just trying to tell me what. Yes, I need the number and what type of slope. There's your perfect triangle. So that's your run. Nice. There's your rise. Perfect. So he drew his perfect triangle on the bottom side. Is that totally possible to do? Yes, 100%. Just as long as you know which one's the rise and which one's the run. Okay? Nope. Not yet. Okay, so this is what he got for my video notes people. And that's in simplest form, okay? Who would like to do 14? Corbin? I'm just trying to write it down for my video notes people. Okay, so we found our perfect right triangle. We went down on the rise, -2, and we ran 4. So I have -2 over 4, and then that fraction can reduce to -1/2. 1/2. Sweet. Questions, comments, concerns? Jack, do you mind going up there and erasing what was written? Thank you so much while I turn the page. Thank you, sir. All right. Now let's talk about the slope formula. You're not going to be given a graph every single time. So you need to know the formula to solve. This formula is as such. M equals, what does M represent? The slope. So the slope equals y2 minus y1 over x2 minus x1. Now, I don't want you to be confused. This is still the rise over the run. It's still rise over run. It's just I don't have a graph. I only have ordered pairs or a table, and I got to use that to help solve. But it's still rise over run. Now, there are certain steps that you have to follow. Step 1, and yes, I want you to write this down. Step 1, label the ordered pairs. Label your ordered pairs. Now, how do we label the ordered pairs? Great question. In the equation, we have x2, y2, y1, x1. Those are the labels. The question is, what gets what label? Now, ordered pairs are always written as x comma y. Would y'all agree? Hopefully y'all do. Okay? Ordered pairs are always written as x comma y. Now, what dictates what is x1, y1, and which one's x2 is y2 is literally the order in which they give them to you. 1, 1 and 4, 3. Which one is given to you first? The 1, 1, correct? That is going to be your x1 and y1 because it was given to you first. Which means the other ordered pair is x2, y2 because it's given to you second. So we've labeled our ordered pairs. Step 2. Substitute. Coach Kimball's favorite mathematical principle, because in algebra, you just do it over and over and over again. You just substitute in almost everything we do. Okay? So I have my labels, x1, y1, x2, y2. I'm going to substitute it into the formula that we have now. So I have, how do I want to phrase it? Let me ask you all this. Okay? I have m equals, what is the value of my y2? 3. Good. Now the formula says that I'm going to subtract that with the value of my y1. What is that? What's the value of the y1? 1. And that's my numerator. That's my rise. I like to scratch them out after I use them. Okay? The denominator is x2 minus x1. What is the value of my x2? What is the value of my x1? And we're subtracting because that's what the formula says. Step 3, and which is technically the final step, Simplify. What is 3 minus 1? What is 4 minus 1? Can that be reduced? So guess what? That's your answer. That is the answer. It's easy, right? Probably wasn't easy last year, but I feel like hopefully I'm explaining it a little bit better. Okay? So, step 1 is what? Label the ordered pairs. Now, how do I know which one is my 1s and which one's my 2s? The one that comes first. So, x1, y1, x2, y2. After label, what's step 2? Substitute, okay? What is the value of my y2? -2. The formula says it must be subtraction. What's the value of my y1? 4. Okay? What is the value of my x2? 10. The formula says it must be subtraction. Now I ask, what is the value of my x1? -2. All right. Yes, I can have a minus a negative. I can have that. This is why I want you to have your calculators. Turn them on. Watch what I do. Everyone hit alpha x. Alpha x. Do you get a fraction bar? Yes. I'm going to put this in the numerator. -2 minus 4. I'm going to scroll down to the denominator. And I'm going to put 10 minus -2. See that? I just wrote what I put. Now from here, I hit enter. What do I get? -1/2. You know what's amazing about the calculator is not only did it solve it, but it also simplified your fraction to its lowest term. Yes?
So, will we ever, substitute? I did, 10 minus 2 or do we have to be,
You just did 10 minus 2? Is that what you said you just did?
Yeah, so does it really matter?
It absolutely matters. Okay, now this is why I've been phrasing what is the value of x1? What's the value of x2? I've been really specific about what I'm saying is because even though the problem says minus, that doesn't take away that negative that was in there. Okay? That minus does not get taken away just because we have a subtraction sign here. So that's why I've been phrasing it as what's the value of x1. It's -2, so I'm going to put all of -2 in there. Okay? Guys, we can use calculators. Why make it complicated? I'm here. That's a lot of math that I don't want to do because I have to, first of all, subtract these, get a value. Then I have to see if I need to reduce the fraction when the calculator does it all for you. It does it all for you. Use our tools. Okay? All right, we're going to talk about 2 more of the ordered pair versions. Now I'm going to draw a line here. I'm going to draw a line here because I'm separating 7, 8, 9, and 10 from the ordered pairs. The table is a little bit different. All right. Step 1, label your ordered pairs. Okay? I have my x1, y1, x2, y2. Why is this ordered pair the 1s and why is this one the 2nd? Because it comes second and that one comes first. Simple as that. It's not complicated. Once I've labeled, I now do what? Substitute, Coach Kimball's favorite mathematical principle. So what is the value of my y2? What is the value of my y1? Okay. What is the value of my x2? What's the value of my x1? Sweet. Now, I personally, this is easy stuff. I'm not even going to plug it in the calculator. It's easy. What's 9 minus 9? 0. 3 minus 5 is negative 2. Okay, now that's that right there. If I go to my calculator and I type in 0 divided by negative 2, am I going to get an error message or am I going to get 0? I'm going to get 0. And any time that I get 0, my slope is the word 0. When 0 is in your numerator, your slope is 0. Okay. Looking at 6, speed the process up just a little bit. So now I have 5 minus 8 over. Now what's the value of my x2? Negative 7. The formula says it must be subtraction. What's the value of x1? Okay. So 5 minus 8 gives you negative 3. Okay. Negative 7 minus negative 7 gives me 0. If I do negative 3 divided by 0, what's the calculator going to do? Error. Okay, it's going to be an error. So anytime I have an error, my slope is undefined. Now, let's look at something. Helpful hint. Isabella. Head up, please. That's not head up. You just turned your head. You still just turned your head. You're still turning your head. There it is. Okay. Let's look at something. When 0's in the numerator, our slope is what? 0. When 0's in the denominator, our slope is? That's your helpful hint. That's the hint. Got it? Easy peasy? Kinda? Okay. All right, tables. Tables are different than ordered pairs, okay? Because we can work within the tables. Now, the table slope is going to be m equals what's called delta y over delta x. That is a triangle. But I'm saying the word delta. Delta is a part of the Greek alphabet. Now, we use this word / symbol delta to mean the change in ... Now, I'm putting ... because it's whatever comes after it. So this is delta y, but what it really means is the change in y divided by the change in x. You know what that really means? Rise over run. It's still rise over run. Okay? So horizontal tables, your x's are on the top, your y's are on the bottom. Okay? Just make sure that when we convert it to slope, y is the numerator and x is the denominator. Okay? Now to go from -4 to -2, to go from -4 to -2, you go up 2, which up 2 means +2. To go from -1 to 1, -1 to 1, what do we do? +2. This right here is our change. This is the change. This is our deltas. These are our deltas. So my change in my y value was 2. The change in my x value was also 2. What does that simplify to? 1 whole. And that's your slope. Slope is 1 because it's 1 whole. All right, we're going to skip 8 and 10. I want to look at 9 because it's a different table, and due to time restraints, we move forward in our program. Okay, vertical table. In a vertical table, your x's are always on your left, your y's are always on your right. We just took a test with tables like this. Okay, just like on our maps. We still do the change. From 3 to 5, what do I do? Plus 2. From 14 to 9, what do I do? Say it again. Minus 5. Minus. Because I'm going down. The way you write it. This is your change in y, so that's your numerator, negative 5. Your denominator is the 2, because that's your x values. Can that be reduced? No, cannot be reduced. Okay, I can make it a mixed number, but are we making these into mixed numbers in this unit? No, keep them improper. Box that answer up. Y'all give me one quick second. Cool. Thank you. Awesome. Wonderful. Grand. Questions, comments, concerns about tables? Questions, comments, concerns about ordered pairs? All right. Now we're going to get into the actual complicated part of today's lesson. Working backwards. And what I mean by working backwards is I give you the slope. You got to tell me the missing ordered pair value. Okay? So, for example, if the slope of the line passing through these points, well, here's my first ordered pair. Guess what? What am I labeling that? X1, Y1, because it's the first ordered pair given to me in the problem. Then I have the word and another ordered pair. That's my X2, Y2. What is different about this ordered pair? There's a y in there. So do I know that value? No. It's my goal to solve for that value. Okay? Then I finally put is negative 4/5. This is your m. That's your slope. When you see the word is, that's your slope. Remember slope formula? Okay, I'm going to write it up here. M equals y2 minus y1 over x2 minus x1. Okay? I'm going to use that. Here's my equals. That's my is. That's my is. That's how I know that that's the m. Does that make sense, Izzy? Okay? So, I'm going to rewrite this, but I'm going to go ahead and substitute. Everything's still the same. Step 1, label. Step 2, substitute. So, m is negative 4/5 equals, what is the value of y2? Y. Perfect. Minus, what's the value of my y1? Perfect. Okay. What is the value of my x2? And the value of my x1? Perfectamundo. Step 2 is substitute. We substituted. We're missing a value. Okay, so step 3 is going to be solve. Simplify. Same thing. They're synonyms. Okay, simplify. 5 minus negative 5 is what? Huh? 5 minus negative 5? Y'all all have calculators? Xavier? 10. Thank you. So I have negative 4/5 equals y minus 6 over positive 10. Stay with me. Stay with me. Okay, I'm going to ask you a question. I know what my denominator is. Okay, I'm going to ask myself this question because I have an equal sign here. I can ask this question. Does 10 equal 5? No, I'm only looking at the denominators because that's what I actually have. I have all those values. Does 10 equal 5? No, but I have a fraction, so I can make it equal 10. Instead of reducing a fraction, I'm going to increase the fraction. How can I make this 5 a 10? Say it. I can multiply this fraction by 2. Now, that gives me, okay, now I'm going up here. That gives me 10, okay? What is 2 times negative 4? Because remember, your negative will always be with the numerator because of the rise and run, or because of the rise up and down, okay? What is negative 4 times 2? Negative 8, okay? Then I have my equals. I have my 10, and then I have my y minus 6 right there. Do these now equal each other? 10 equal 10. Okay, really technical thing I'm about to do here. You really need to pay attention. I'm going to cross them out. Very technical. And what am I left with? Negative 8 equals y minus 6. Have I been doing this for the last 2 units now? Solve for the missing variable. How would I solve for y in this situation now? Add 6 to both sides. Zero pair. Negative 8 plus 6 is? Negative 2. Negative 8 plus 6 is negative 2. So the whole goal is to eliminate either the numerator or the denominator. In order to eliminate the numerator or the denominator, I must have equal numerator or denominator on both sides of the equal sign. They must be the same. Then we can cancel them out, and I'm just left with what I need to solve for the missing. I'm going to do one more example on this one, and then I'll let y'all go. Okay? So here we go. I have a slope of 2, and I have my ordered pairs. Again, the first ordered pair I'm given, make that your x and y1. The second ordered pair I'm given, x and y2. This problem, I'm solving for an x this time. I solved for a y in my first example. Now I'm solving for an x. Remember that the equation, m equals y2 minus y1 over x2 minus x1. Okay? No, you don't have to have this memorized. It's on the formula charts that you get on the STAR test. My formula charts for my class are right over there by the calculators. Those green sheets of paper by the calculators. So when we're done with this, y'all can all go grab it so you have that in front of you when you do your homework. Okay? Get used to grabbing those from here on out. So here we go. I have my m. I'll substitute that in. 2. However, I need a denominator. How do I make a whole number a fraction?
1.
Put it over 1. Good. Okay? Now I have my y2 minus my y1 over my x2 minus my x1. Step 1, label. Step 2, substitute. Done and done. Step 3, simplify. 6 minus negative 2, due to time restraints, I'm going to move forward in our program. That gives you 8. X minus negative 3. What's that actually doing? It's the same as x plus 3. Okay, same as x plus 3. subtracting a negative is the same thing as adding a positive. So when I simplify this, I'm simplifying it to now x plus 3. Okay? Now, the variable that's missing is in the denominator. Do you agree with that? Okay? What I have is a numerator of 8. What can I do to get my slope to have a numerator of 8? Times 4. Now, we're not doing 14, so I'm going to use that space over here. So now what I have is I have 8 over 4 equals 8 over x plus 3. Do I now have equal numerators? Can I cross them out now? Yes. What am I left with? 4 equals x plus 3. Can I solve 4 equals x plus 3? By doing what? Minusing 3. Minusing 3. 0 pair cancels out. I'm left with x equals 4 minus 3 is 1. 1 is the loneliest number that you'll ever be. Yep. It's solving equations. What we did in Unit 1. Questions, comments, concerns, tribulations, or hinklepinks? Kerfuffles, conundrums, quandaries? Questions?